It is my great pleasure to introduce the keynote speaker for this session, and it's David Fraser, Dr. David Fraser. And David is a professor of animal welfare at the University of British Columbia in Vancouver, Canada. His research career has focused on behavior and welfare of farm and companion and wild animals. He has served as a scientific advisor on animal welfare science and policy to many organizations, including the World Organization for Animal Health, the Food and Agriculture Organization of the United States, and the Food Marketing Institutes in Washington. Professor Fraser is an enthusiastic teacher who mentors many graduate students and teaches undergraduate courses on animals and animal welfare. He is the author of many publications, including the popular introductory book, Understanding Animal Welfare. Over to you.
Thank you, Cynthia. Good. Thank you again, Cynthia, for the kind introduction. Thank you to the organizers for putting together such a stellar program. Extremely interesting thus far. I can't do voiceovers for turtles. And thanks to all of you for the honor of being able to share some thoughts with you this morning. I wanted to touch principally on animal welfare science, a little on its beginnings and key elements, and then most of the time on some interesting new developments. In 1964, an English woman named Ruth Harrison published this book, Animal Machines, which had a foreword by Rachel Carson, who had published Silent Spring 2 years before. And in Britain, this book galvanized public concern about farm animal welfare, much as Rachel Carson's book had galvanized concern over pesticides in America. The book described the then new intensive husbandry systems, things like battery cages for hens. And Mrs. Harrison claimed that these are so unnatural that the animals must surely live miserable lives and be unhealthy. It created a huge stir in the United Kingdom to the point that the British government was described as inundated with calls and letters from concerned citizens, worried that they were supporting cruelty to animals and poisoning themselves on unsafe food at the same time. The government responded by creating an advisory committee, one of whose members was William Thorpe. Thorpe was an interesting Quaker pacifist scientist, best known for his studies on birdsong. And as part of the committee report, he wrote an essay called The Assessment of Pain and Distress in Animals, 1965. He cited physiological indicators of stress, behavioral indicators of pain and discomfort, motivation that is thwarted in confinement, the intelligence and cognitive powers of animals which may make them, give them difficulty in barren, unenriched environments, fear of humans, preferences of animals for different environments, and suffering caused by disease and injury. Well, obviously, impressed by Thorpe's program, the committee called for research to be done on animal welfare, partly to make systems more humane, and partly to make them more efficient by better accommodating the needs and nature of the animals. The major result of this report was the launching of the field which we today call animal welfare science. A second result was that a lot of the emphasis and early work was done on the farm animals. That continues to be the case, and so many of the examples I'll use today are taken from the farm animals, but I'm sure you'll be able to see the applicability. And a third and very minor result was the creation of the first position at the University of Edinburgh for somebody to do research on the welfare of pigs, which was filled by a very undistinguished Canadian who knew almost nothing about pigs and even less about how to use science to understand their welfare. As the science emerged, people began to discuss, well, what is it that we mean by animal welfare? What's the goal of all this? And the discussion crystallized around three main ideas. One was the basic health and functioning of animals, freedom from disease and injury, evidenced by things like normal lifespan, growth, and reproduction. A second concern was the affective states of animals, those states that animals experience as positive or negative rather than hedonically neutral, things like pain, hunger, and fear, running through to pleasure, comfort, and so on. The third concern clustered around the concept of naturalness, sometimes a little ill-defined, but basically meaning environments and diets that are natural for the species and that allow the animals to perform natural behavior and make use of their natural adaptations. So if we were to summarize this, we could say that to accommodate animal welfare, we want to ensure that the animals are healthy, happy, and have reasonably natural lives. Now, of course, different groups emphasize the three areas to different extents. Veterinarians and animal producers, with their focus on health and productivity, for them, a good life for animals must first and foremost be a healthy life, even if that's achieved by some unnatural means such as using confinement systems to maintain herd health. For people in the humane movement, with the traditional emphasis on preventing suffering and cruelty, a good life must first and foremost be a happy life with a minimum of distress and pain. And for, as we're finding, urban residents who tend to idealize nature, family farming, and rural life, the good life for animals must first and foremost be a natural life. Now, sometimes these come into conflict, and resolving these conflicts when they don't agree is one of the ongoing challenges. But as the science began to be done, it became clear that scientists are actually people, and they too had these same sets of values and concerns, and all three formed the basis of the emerging science. To start with the basic health and functioning work, here's a very young Ingvar Ekesbo. Ingvar is a Swedish veterinarian, still active in his 80s. In the early 70s, he conducted some of the earliest work bringing epidemiology into the field of animal welfare science. He visited hundreds of Swedish dairy farms and looked at how different features of the environment influenced animal health outcomes. Here is just one example showing that whether the animals were loose-housed or tied, the incidence of mastitis was half on those farms that used bedding compared to those farms that didn't. This was early 70s. It was one of about 75 tables in his report, all done before the advent of computers, and if you could imagine the amount of hand calculation that this involved. This work, this comparison of facilities, an epidemiological approach, has gone in some interesting new directions. One we might call comprehensive welfare assessment, best examples being the so-called Welfare Quality Project in the UK. Here are their assessment protocols for cattle, assessment protocol for poultry. These tend to be quite comprehensive, covering many different features of the farm that may contribute to animal welfare. They generally lead to an overall score by giving so many points for different features, and that may lead to a pass-fail or a classification from somewhere between excellent to unacceptable. They tend to take a long time to do and require some specialized skill. Here's a slide that I don't intend you to read, but merely to marvel at its length and complexity. It's the first few items of one assessment scheme, requiring that animals are allowed to lie down, to rest, to stand up with enough space for physiologic movement, to perform licking and social interactions. Tethering is appropriately arranged. Wounds are not found at tethering. Shelters are made from resistant materials, waterproof, draft-free, easy to clean, and so on. The approach is controversial, partly because it assigns weightings to different aspects of animal welfare, and there is simply no objective way to say that freedom of movement is worth 5 and freedom from salmonella is worth 8. Partly because there is a large focus on the facility itself rather than the welfare outcomes, and we all know that we can get very different welfare outcomes from similar facilities. And partly, I think, because the owners tended to feel that people were sitting in judgment on them. A superficially similar, but in my opinion, very different approach has been called welfare benchmarking. Here, people generally use a small number of variables. They tend to be outcome variables, such as the incidence of lameness. They are not combined into any overall score or pass-fail. The idea is simply to communicate to the operator how their unit is doing on certain uncontroversially welfare-relevant variables compared to other facilities. My colleagues in Vancouver have done this on many, many dairy farms, scoring things like the percentage of cows that are lame and the percentage that have these kind of leg lesions shown here in the center and the right hand, as opposed to the healthy leg on the left. Some fairly typical results. Here are 40 farms, all from one area, arranged from best to worst, and we're seeing the percentage of lame cows going from about 12 up to an appalling 85. And here are those leg lesions going from an average of about 15 up to 100% of cows on some farms with these leg lesions. This information is then turned into a report with display elements such as this, showing that in this area, lameness goes from 5% under good conditions up to a high of 89%, and this particular farm is coming in at 57. Well, what does this achieve? The thing is, farmers and operators of those kind of facilities don't have much occasion to see how their operation compares to others. For many people, this comes as a huge revelation. And the producers are so intrigued by this that they want this done as a service, and in fact, a company has now hired several of our graduate students in order to deliver this as a service to farmers. And simply the information seems to motivate change. Here was a study of 15 farms that were visited 2 times a year apart. Here was the incidence of lameness the first year, running from about 30-some% up to 80-some%. Coming back a year later, after the farmers had received this information, some of them hadn't changed, but many of them had, and in some cases the improvement was dramatic. Here's the incidence of leg lesions in the first year and leg lesions in the second year. A few hadn't changed, many had, and some cases the changes were dramatic. Why is this? In my experience, people who look after animals really want to do a good job. And this kind of information can turn this general motivation into specific goals and actions. But I want to come back to this slide of lameness showing farms ranging from 12 to 85% of lame cows. These are the same breed of animal, the same type of housing, the same climate and area. How can it be that we have such different welfare outcomes? I think the answer is that providing animal welfare is a complex and skill-demanding activity that different people do with much different success. And we see this all the time. So foot lesions in chickens, some farms at 0%, some going up to 88%. Piglet mortality, 5% on a good farm, going up to 24% on a bad one. The thing is that the animal welfare is influenced by the physical environment, nutrition, healthcare, genotype, handling, and these things interact, so the type of handling that works in one physical environment or with one genotype does not work well in a different environment or a different genotype. Managing this complex skill and knowledge demanding situation is something that some people do much better than others. I think the message that we are gradually learning on the farm side is that to improve animal welfare takes much more than ticking boxes about the features present in the environment, and that what we need to do is move from an industrial model more toward a professional model with all of its emphasis on skills development and standards. Of course, this takes us back to some of the basic work on stockmanship done by Paul Hemsworth in Australia and his recent book, Human-Livestock Interactions. Paul and his group have done dozens of studies comparing farms and coming up with very fundamental results showing how the handling that the animal receives influences such basic outcomes as health and productivity. Just one study on dairy farms showing that the amount of negative handling of the cows, slaps, hits, pushes, and tail twists, correlates positively with the avoidance of a handler in a standardized test, positively with the amount of stress-related hormone cortisol in the milk, and negatively with the yearly milk yield. This and many other studies led Paul to propose a simple model whereby negative handling, including unpredictable or inconsistent handling, can set up a chronic fear of humans in the animals, leading to a classic stress response, leading to reduced growth, reproduction, and immune competence, and that the selection and training of the workers is a major way to overcome this. From the beginning, it was clear that the affective states of animals had to be a key part of any legitimate science of animal welfare. But this created a problem. Back in the 60s and 70s, many people were working with the view that the emotions and cognitions, other experiential states of animals, somehow fall outside the realm of scientific inquiry. In highly influential book, Behaviorism, John Watson wrote, "The rule is, can I describe this bit of behavior I see in terms of stimulus and response?" And the behaviorist has dropped from his scientific vocabulary all subjective terms such as sensation, perception, image, desire, purpose, and even thinking and emotion. And with that in mind, several generations of behavioral scientists had grown up believing that the affective states of animals somehow fall outside the realm of science. So when we wanted to do a science of animal welfare, clearly we needed a new paradigm. All right, let's take a simple practical example. Here is a piglet who has been isolated from its mother and litter mates. When little pigs get separated in this way, they do a number of characteristic things. They show increased running and walking, jumping against the walls, defecation, and an increased rate of calling, increased loudness of calls, and an increased pitch of calls. It's very characteristic. Anyone who walks into a barn and hears this knows that a piglet's out of its pen. Here's a sonogram of the calls, showing about 9 calls over a 4-second period. The first two are made quite low calls, probably made with the mouth closed and sounding like The next two have more energy and around the 400 hertz range, probably made with the mouth open, so you've got a higher harmonic, ah. Then we've got calls that start with that grunty component but jump up to a high pitch. So these are ai, ai. So here we have ai. Now, I knew you would not want to leave the singing to me, so I've transcribed this into standard musical notation so that we can all join in. You'll notice that it is marked por cabili con spiritu with a pig-like voice and with spirit, and there is a crescendo at the end. So, we'll just so that no one has any excuse not to participate, we'll slow this down to half speed and make it very easy to sight read. On 3, please. Whoops. Ready? Sorry, on 3. 1, 2. Ah, ah, aye, ah, aye, aye, aye. Good, thank you very much. Well, here are some data to show that this isn't purely an exercise in frivolity. Here are some data showing that when a piglet is moved to a new environment, the amount of that squealy vocalization is very high if it is alone, almost 0 if the mother and litter mates are present, and the presence of a few litter mates is about as effective as the presence of the mother in reducing this. So if these calls represent a state of separation distress, then when the animals are moved to a new environment without the mother, at least keeping litter mate groups together can help relieve that distress. Just as a personal point of interest, that paper came out in 1975, which means that I collected those data almost exactly 40 years ago. All right, but are we just being anthropomorphic when we say, well, this represents a state of separation distress, or is it really part of the science? In Watson's paradigm, we're trying to link stimulus with response. So here are our various, various responses over here, and we know that they are elicited by a whole bunch of stimuli over here: separation from the mother, separation from litter mates, unfamiliar environment, restriction of movement, cold environment, no recent feeding. All of those have been shown experimentally to give rise to these responses. If we were to pull a John Watson, linking stimulus and response, we would need a plateful of spaghetti to create enough arrows to do this, and it would have relatively little simplification or predictive value. If instead we postulate that these conditions on the left, are leading to a state of separation distress, and that the responses are an evidence of separation distress, then we have a much more manageable explanatory model, and one that makes lots of predictions about, for example, how pharmacological interventions would influence the whole suite of responses. So this is not superfluous to the science. It's inherent in the science. For at least a century, physics and chemistry have improved their explanatory models by postulating entities like electrons and Higgs boson that can't be observed directly. I would say, by analogy, it is not outside the realm of science, it is embedded in the science to postulate such states in animals and use them, explore their properties, and use them in our explanatory models. All right, with that element of preaching, I'm sure, to the converted, let me touch on a few new developments, one being facial grimace scores for detecting pain. Of course, this is nothing new. Even without hearing the cry, it's no secret that we are looking at an infant in some form of distress. And specifically with infants, signs that have been used for pain include bulging of the brow, squeezing the eyes closed, opening the mouth, pursing the lips, holding the tongue taut, and quivering of the chin. And use of those signs combined with vocalizations and heart rate have now convinced the medical profession that infant circumcision does cause pain, and shown that it can be mitigated by topical anesthetics. And I believe that is now the established procedure, which it wasn't 20 years ago. Could we do this with other species? Actually, there's some nice work on mice, normal face on the left, pain face on the right, and actually using some of the same elements, such as bulging of certain muscle groups and the closing of the eyes. And horses, normal face on the left, pain face on the right. The score that's been developed for horses includes the ears being stiffly back or sideways, tension above the eye area, orbital tightening again, prominent strained chewing muscles that you would get with a kind of clenching of the jaw, strained nostrils and flattening of the profile, and mouth strained and a pronounced chin. This has been turned into a fairly simple facial scoring key for horses, and as an example of some of the results, here are 3 groups of horses in a castration study. The ones in the gray here were the sham uncastrated control beforehand and showing no change after castration. The other 2 groups were castrated using 2 different pain management protocols. What we see is a huge increase in the facial grimace score after castration, and it looks as though neither of the pain management protocols was all that effective. This has now been developed into the Horse Grimace Scale app for your smartphone, which is available at the Animal Welfare Science Hub, www.animalwelfarehub.com. It's a relatively new site trying to be a kind of global resource for animal welfare science and developed under the AWIN project, the Animal Welfare Indicators Project. All right, a second very different approach has been called qualitative behavioral analysis, this one pioneered by Françoise Wemmelsfelder in Edinburgh. The idea is to use the most powerful pattern recognition software yet developed, which is the human brain with its trillion neurons and 100 trillion dendritic connections, to recognize affective states in animals by picking up subtleties in behavior. Even from still photographs, we can probably distinguish an alert, inquisitive animal from a withdrawn, defensive animal, and imagine how much more easily that could be done if we saw it in real time. Of course, the classic objection is that animals may have certain gestures that we simply misinterpret. Classic example would be this face from a chimpanzee, which a naive person might see in a photograph and think it represents a yawn or even amusement. But when we see it in the context of the full body language, and again imagining seeing this in real time, it becomes clear that it's a threat, right? The process started with a technique called free choice profiling, a method borrowed from the sensory evaluation of food by food science people. The idea is that an observer observes a group of animals and selects their own adjectives to describe what they're seeing. Are the animals curious, aggressive, frightened, bored, and so on, and scores each individual according to how much they feel that trait is present. Then through a really hairy statistical technique called generalized Procrustes analysis, which is related to principal component analysis, those words and numbers are manipulated into what look a lot like principal components. Here we see one observer looking at a group of pigs, and the word chart came out as a scale here running from confident, relaxed, playful, bold, friendly, curious up at the top, down to wary, suspicious, timid, and nervous over here, and a second dimension, angry and irritated over here, calm and gentle over here. Second observer with the same group of pigs, and here we've got confident, friendly, curious, bold, interested, forceful, coming down to hesitant, shy, anxious, and stressed, and over here, frisky and aggressive versus calm, quiet, and gentle. There is a high level of agreement, even though people are using their own choice of adjectives in the case of free choice profiling. This has been validated in various ways. Here was one experiment where pigs were given either the tranquilizer azaperon or a saline control, and scored then on this axis from confident and exploratory down to nervous and fearful. Obviously, the animals with a bit of tranquilizer scored much higher on the confident exploratory scale. This has now morphed into qualitative behavioral analysis, where people are actually given preset adjectives in order to make this more simple and standardized, those adjectives having been developed through the free choice profiling. So things like active, relaxed, comfortable, fearful, and agitated. People simply mark how much they feel that trait is present in a given animal. And then principal component analysis pulls out the components. Here is one interesting result for growing pigs. And the principal scale, accounting for 79% of the variation, runs from content, happy, enjoying, positively occupied, down to bored, aimless, and frustrated. This looks a lot like a scale that we might call positive to negative affect. And the method looks a lot like a way of taking our, shall we say, intuitive, perceptive, qualitative observations and turning them into a quantitative score that represents a scale running from positive to negative affect. My third example has been beautifully described already, cognitive bias. Brought into the animal welfare literature by Mike Mendel and his group in Bristol. Since it's been so well described, I'll just for one or two that weren't here, the idea, of course, coming from human psychology and the observation that people who are in a negative state such as depression tend to interpret things pessimistically. So for them, this is a bad thing because the glass is half full, whereas a person in a positive state sees it as a good thing because the glass is half empty. The happy person sees it as the glass half full. Just a quick example of using this with calves. Here is a calf that has been restrained for hot iron disbudding, hot iron dehorning. This consists of heating a ring-shaped metal iron to 600 degrees Celsius and pressing it against the head of the calf for maybe 20 seconds to cauterize through all the tissue that would allow the horn to develop. Of course, it's done with sedation and local anesthetic, so the calf shows no immediate reaction. But in the following day or two, is it still in a state of chronic pain or malaise? Here was a testing paradigm to see whether the animals are showing cognitive bias under those conditions. The calf, you're seeing his rear end here, is put in a room with a computer screen and a nipple that feeds it milk on your left, where the calf's head is out of view. Basically, if the computer screen is white, the calf should touch the screen and it triggers release of milk. If the screen is red, it should not touch the screen because doing so will cause a timeout when everything goes quiet for a while. Calves learn to do this beautifully, and when they're well trained, with the positive and the negative, they're then given intermediate stimuli, which are ambiguous shades of pink. Tested before the dehorning, we see a sort of classic result, 100% response when the screen is white, 0 response when the screen is red, and the shades of pink are producing something intermediate. On the day after dehorning, we see the same response at the top and bottom. This is not just a general reduction in response rate, but certainly a specific reduction in some of the intermediate stimuli. So with the concept thus proven, we hope to use this kind of approach to ask more subtle questions, such as whether affective state is altered when environmental enrichment is added or removed, handling is changed, social partners removed, and so on. Right, turning to the third main theme of providing animals with more natural living conditions. Of course, the critical issue about battery cages and other such environments is that they're highly unnatural and don't allow animals to perform natural behavior. One of the early responses was experiments like this, where colleagues of mine in Edinburgh turned pigs loose in a wooded hillside area, watched everything they did, and then tried to develop a designed interior environment that would allow the animals to express all the types of behavior in their natural repertoire. As this work was evolving, people came to realize, of course, that natural behavior includes things that animals want to do, like eating and playing, and things that animals don't want to do, like shivering in the cold and fleeing. So how do we decide which are which? In fact, we can think of behavior as falling into a kind of 2-by-2 table, either natural or not natural, and either preferred or not preferred. For animal welfare purposes, we generally don't try to accommodate behavior that is natural but not preferred, things like shivering and fleeing, nor do we try to accommodate behavior that is preferred but not natural, such as eating rich food, taking addictive drugs. What we want to accommodate is the behavior that is natural and that the animal prefers to do, will work for the opportunity to do. The classic way of identifying these types of behaviors has been some form of preference and motivation research. For example, hens can be taught to peck a key in order to get a reward such as food, and we can use other responses for animals to learn to obtain other kinds of resources. To cut a very long story short, the hen really wants to achieve three things: a nest box where she can retreat to lay eggs, a perch where she can rest at night, and a dust bath where she can carry out dust bathing. Europe has now made that system mandatory, and in North America we're starting to see very enriched, designed environments like this based on those three principles. A second way to achieve that, to identify those types of behavior, is through identifying behavior that reduces stress. My favorite example is the interinstitutional study of clouded leopards led by Nadia Wielebnowski, which showed that multiple regression analysis of fecal corticosteroid metabolites as an indication of activation of a physiological stress response. These were not related to the area of the enclosure, but were highly related to the enclosure height, because in the high enclosures, the animals were able to get up on a high perch. So perching for this species, and probably for many cats, is an important natural behavior because of its role in stress reduction. Finally, I want to run past you the hairiest idea of all, this one, trying to link natural behavior and affect. If we take an evolutionary view, we can see that animals' decisions about what to do when can be broken down into two problems. One is to act in a way that addresses immediate threats to fitness. So things like fleeing from danger, withdrawing from injury, drinking when seriously dehydrated, and eating when starving. These have to be done quickly in order to respond to some challenge, and maybe we could call them needs. With those things out of the way, it is advantageous for the animal to do other things that are beneficial for fitness in the long term, but not in response to any particular emergency. Things like playing, which helps to improve motor skills, grooming, which helps to maintain coats, resting, eating when palatable food is present to take advantage of that, even if there isn't an immediate need for food. And maybe we could say that these are responding to opportunities. We know from human experience that these ones on the top are accompanied by negative and quite distinctive affective states like fear, pain, thirst, and hunger. The ones on the bottom don't have that kind of distinctive negative affective state associated with them, and the motivation is probably some kind of enjoyment inherent in carrying out that type of behavior. So if this hypothesis is right, then to inject positive affect into the lives of animals, we should look at the natural history of the species, identify those types of behavior that are not done in response to some pressing need, but that probably have some kind of longer-term fitness benefit. And depending on the species, this may be exploring, grooming, renewing territorial markings, other forms of social behavior, perhaps caching food, learning how to control the environment, engaging in cognitive complexity, and so on. All right, I just wanted to end with a little broader context on how animal welfare science relates to traditional concerns like animal husbandry and animal care. A century ago, students studied a subject called animal husbandry, which was the feeding, breeding, healthcare, handling, management, and housing of animals. Starting in the early 1900s, some scientific specialties became established, and animal husbandry became animal and veterinary science. Feeding became nutrition. Breeding became the sciences of genetics and reproduction. Healthcare became the various disciplines of the veterinary sciences. But there was no obvious field of science to deal with the rest of animal husbandry. Mid-1900s, along came two new fields, one being animal behavior, shown here by Konrad Lorenz and his imprinted geese. Second, stress physiology, made popular by Hans Selye's emphasis on how the glucocorticoid system responds to all manner of insults to the body. So when William Thorpe then proposed how science could be applied to address animal welfare, these two fields figured very prominently in his recommendations, quickly followed and joined by the epidemiology of Ingvar Ekesbo, the stock person behavior work of Paul Hemsworth and others. And I think what we have now is animal welfare science as finally providing the scientific basis for the missing pieces of animal husbandry. But of course, animal welfare also depends on feeding, breeding, and healthcare. And so we're seeing animal welfare science more as an integrative lens to provide a more comprehensive scientific basis for animal husbandry and animal care. 3 take-home tweets. 1, that traditional concern over animal welfare is that animals should be healthy, happy, and have reasonably natural lives, and that science has built on all 3 of these ideas. 2, that we've got some interesting new developments, welfare assessment tools, including benchmarking, detecting affective states by facial recognition, qualitative behavioral analysis, and cognitive bias. And 3, identifying important types of natural behavior by preference and motivation research, stress reduction, and the link between behavior and affect. And finally, that animal welfare science is providing us with an integrative science of animal husbandry and animal care. And for those who want more details, they're always there. Thank you very much.
Thank you, David. What a great entree to the next talk. We actually have enough time for 1 or 2 questions as the next group of speakers is coming forward. So does anybody have questions they would like to address to Dr. Fraser? I can't even see. Yes, up here.
David, one of the elements that I think you missed in terms of the affective states is a drug treatment. That administering anxiolytics or drugs that we know affect us in certain ways then produce the same benefits or the same change in behavior in the animals.
Yes, of course. The azoperone, for example. Yeah.
So I'm going to be a little bit critically anthropomorphic here. In a human life, we wouldn't think that a life that's completely without frustration or challenges or threats is, a valuable life. And there is work done in Karlstadt, and a number of people showed that with animals in the zoos, giving them predators and odors and things like this actually is a good thing to do. It stimulates them and makes them more alert and aware. How could this be figured into your model here?
Okay. This is part of the debate between the 3 circles. So those emphasizing the naturalness thing emphasize that, okay, some pain is inherent in life, some fear, some cold, and so on, whereas others are trying to emphasize the health and the lack of pain and distress. So it's one of the issues, it's one of the debates, a critical thinking point, and a point of some real disagreement, for example, between organic farmers who want the animals in a natural condition, even if they're not really as healthy or stress-free, and more conventional farmers who feel that it's better for animal welfare to solve those, what they see as problems. I don't think there is an answer that will please everyone, but it is certainly one of the critical debates.
Okay, thank you very much.
I want to jump in on that last point because I think it's a very important one. In the field of stress, there is the term stress and there's also the term distress, the concepts. I think the issue is that for all living things, the ability to cope with whatever stress you're presented with is the key. And so presenting, for instance, zoo animals, to make this real, presenting zoo animals with stress that they have the ability, either the natural ability or they're living in a physical and social environment that allows them to cope with that stress, is probably not ultimately a negative thing for them. It is part of their environment and they adapt to it. I think generally we take shortcuts when we talk about stress, and we're talking about stress in a sense that this is something that an animal can't cope with, either because it isn't equipped to or because we haven't given it a physical and social environment that allows it to cope with that stress.
Can I just respond quickly to that? That's a distinction between acute and chronic stress that I think is very important, and ability to the animal. Like, there was a controversy about keeping primates together versus solitary that they were, because if they were together, they might fight, they might have social dominance relationships develop, and that's a bad thing if you're the subordinate. And so that was the argument going on there. Again, bringing in stress.
Well, again, but in those social environments, in a natural setting, animals that are too stressed will leave. Well, right. They'll leave. I mean, this is, kind of fundamental. You have to be able to escape. And in a zoo setting, if you can't escape from that social aggression, that becomes, it isn't just acute. It becomes something that is not solvable.
Okay. Which is why I was so happy to see on the next part of the program, or later in the program, a paper on control as a key element in animal welfare. I think the point, though, goes back to the brilliance and ego of Hans Selye, who was advised not to call this general response system involving the adrenal cortex stress, unwisely did so, and then had to go back and say, oh, well, there's good stress and there's bad stress, and created a huge amount of confusion. We want the body's systems to be activated, not too much and not too little, and particularly in a way that the animal can control.